Good evening everyone. So recall that in the last class we have discussed how do we solve a homogeneous linear system of equation with constant coefficient. We haven't done the examples which we are going to do in the today's class. For the given homogeneous linear system in equation 1, we assume the solution of the form a e raised to the power mt and b e raised to the power mt. We put it equation 2 in equation 1 and that gives us the following homogeneous system of equation. For the non-trivial solution, we take determinant of this matrix to be equal to 0. That gives us a auxiliary equation in M, and from there we'll get two values of M. For each value we have a solution, and we say that if the roots are real and distinct, then the linear combination of these two solutions gives us the general solution. So let's try an example. Dx by dt is equal to x plus y, dy by dt is equal to 4x minus 2y. So now if I have to solve this one, then I will take, so let solution be x is equal to a e raised to the power mt and y is equal to b e raised to the power mt. If we substitute it here, you can observe from here only that instead of x I have 1 minus dx by dt gives me m, a is common and the coefficient of y is 1, and for the other one coefficient of x gives me 4a, so x is getting replaced by a and y is getting replaced by b, plus minus 2 and its differentiation gives you minus m, b is equal to 0. So it means that I will get the following system, homogeneous system of equation. Now for this homogeneous system of equation, to have a non-trivial solution, I will consider, so for non-trivial solution I will consider determinant of 1 minus m, 1, 4 and minus 2 minus m to be equal to 0. This gives me a quadratic equation in M whose roots are 2 and minus 3. Yes, so it means that for each value of M I have to find the solution. But when I have to find the solution would look like a e raised to the power 2t, b e raised to the power 2t, and similarly a e raised to the power minus 3t and b raised to the power minus 3t. But the values of a and b are unknown. So it means two solutions are, this is how they look like. X is equal to a1 e raised to the power 2t, y is equal to b1 e raised to the power 2t, and the other solution is x is equal to a2 e raised to the power minus 3t and y is equal to b2 e raised to the power minus 3t. But I do not know the value of a1, b1, a2, b2. But I have this system of equation in a and b. So if I use this one, let's call this one equation 1, let's call it 2. So let's substitute, putting m is equal to 2 in equation 2 and see what you are getting. So if you put m is equal to 2, so minus a plus b is equal to 0 and 4a minus 4b equal to 0. Now one interesting observation here is that I will get both these equations always same. This is because for the non-trivial solution I am assuming the determinant to be 0, which means that if you see in two variables then you will get two parallel lines, and that's why for the infinitely many solutions you will always get the same equation. So from this you will get a is equal to b, so you can choose any value, or instead of a let's write a1 b1, and so a1 is equal to b1, so let's choose a1 b1 is equal to 1. Similarly putting m is equal to minus 3 into gives you, if you put it and substitute it, you will get 4a plus b is equal to 0, and second one is also 4a. So they are a2 b2 just for the distinction. And now you can choose again any value. Let's say if you choose a2 to be 1, then b2 is minus 4. It means your two solutions are, the first one is x is equal to, for e raised to the power 2t you will get 1 1. So e raised to the power 2t, y is equal to e raised to the power 2t, and x is equal to e raised to the power minus 3t, and a2 is 1, and b2 is minus 4 e raised to the power minus 3t. It means general solution is x is equal to c1 e raised to the power 2t plus c2 e raised to the power minus 3t, and similarly c1 e raised to the power 2t plus, instead of plus, minus 4 would come, so minus 4c2 e raised to the power minus 3t. The only important observation here is that you don't merge minus 4 into c2. Otherwise, it would not remain a solution. These values are fixed. C1, C2 are arbitrary constant. A1, A2, B1, B2 are not arbitrary constant. That's why we found those values of A1, A2, B1, B2 which satisfy the given system of equation. And this is how your general solution would look like. Now, in case of equal roots, recall for the homogeneous system of equation, one solution is a e raised to power mx and the other one is multiplication of x. So a x e raised to the power mx. So in this case, one solution would be a e raised to the power mt, b e raised to the power mt, and the other solution would look like a1 plus a2t e raised to the power mt, b1 plus b2t e raised to the power mt. You can say that, and why we need a1 and b1, it is because if you consider the solution of the form a t e raised to the power mt and b t e raised to the power mt, and if you compute the Wronskian, you will realize that this gives a linearly dependent solution. And since we are looking for Li solution, so we substitute the values of x and y as follows. Yes, things should be clear once we do an exercise. So let's assume that we need to solve the following system of equation. Dx by dt is 3x minus 4y, dy by dt is x minus y. Auxiliary equation can easily be computed, which comes out to be m square minus 2m plus 1 is equal to 0. That gives you equal roots. Now for equal roots, one solution is straightforward. So one solution is x a e raised to the power t and y b e raised to the power t. Yes, let's call it 1, let's call it 2. Now I need the value of ab. So putting m is equal to 1 in 2 gives you the equation 2a minus 4b is equal to 0 and 2a minus 4b is equal to 0. So that's why you can choose b is equal to 1 and a is equal to 2. That gives you x is equal to 2 e raised to the power t and y is equal to e raised to the power t. Yes, let's call it 3. So one solution you got. But recall that the other solution is of the form, second solution is x is equal to a1 plus a2t e raised to the power t, y is equal to b1 plus b2t e raised to the power t. Now the question comes that how do you compute a1, a2 and b1, b2? Yes, so think over it, because now we have the form that how does the second solution looks like. Only missing thing is the value of the constant. So to compute the value of the constant, we should put this solution back into the given equation. Yes, So putting 4 in 1, so put 4 in 1 and see what you are getting. You will get the system of equations e raised to the power t is 3a1 plus a2t e raised to the power t minus 4b1 plus b2t e raised to the power t. The other one is now technically these two equations must be similar. So if you rearrange them, they must be similar, and that's why you can pick any one of them, and from there we will try to obtain the value of a1, a2 and b1, b2. Yes, so if you solve any one of them, for example, if you solve the first one, then you have 3a1 minus a1 e raised to power t would cancel out, so you will get 2a1. Then you have, this is with respect to t, this is minus 4b1 minus 4b1, and then from this side you will get a2. If you solve with respect to t, or let's keep t plus t, so 3a2, and this side is also a2 is there, so 2a2, then minus 4b2t, so minus 4b2, and a2 has already been taken on this side. So if you compare the coefficient, so you will get 2a2 minus 4b2 is equal to 0, and similarly 2a1 minus 4b1 minus a2 is equal to 0. Yes, so the first one is giving me a2 is equal to 2b2, so let b2 is equal to 1 implies a2 is equal to 2. Now you have the value of a2, so this becomes 2a1 minus 4b1 minus 2 is equal to 0, or your a1 look like 2b1 plus 1. Yes, so now 2b1 plus 1, so let b1 is 0 implies a1 is 1. You can choose any value which is satisfying this equation. So it means that your second solution would look like a1 plus a2t. So your a1 is 1, a2 is 2, so 1 plus 2t, and e raised to the power t, and y is b1 plus b2t. b1 is 0, b2 is t, so t e raised to the power t. And now you can write down the general solution. So general solution would be the linear combination. So x 2c1 e raised to the power t plus c2 1 plus 2t e raised to the power t, and similarly y is c1 e raised to the power t plus c2t e raised to the power t. Yes. Third case is distinct and complex roots. So complex roots look like, one is complex conjugate of the other, a plus minus ib. If you recall again the homogeneous system of equation, then with respect to one solution, either a plus ib or a minus ib, we used to get both linearly independent solution. So separately if you see, then two linearly independent solutions looks like this one, but since we are interested only in the real solution, so we will consider one of them. So let's say you consider a plus ib. A plus ib gives us both the solutions. So you consider a plus ib, and you replace a1 star with a1 plus ia2, b1 star with b1 plus ib2. Yes, then e raised to power at is there, and e raised to power ibt would be cos bt plus I sin bt. So now this is how our x and y looks like. Now we consider the real part and the imaginary part separately. That gives us the required two linearly independent solution. So you can try by yourself, or you just need to remember the procedure, that you consider the constant to be a1 plus ia2 b1 plus ib2, and in this form, and then you separate the real and the imaginary part. That gives you the required two linearly independent solution. Things would be clear once we see this exercise. So try to compute the roots. In this case, your equation would look like this one. Please try to solve by yourself first. That gives you the auxiliary equation to be m square minus 6m plus 18 is equal to 0, and that gives you roots to be the complex roots. So I told you that we consider one only. So let us consider m to be 3 plus minus I. So when you substitute m into this equation, so let's call this 1, this is 2. So putting m into, and see what will happen. You will get 4 minus 3 minus 3i minus 2b is equal to 0, and 5a plus minus 1 minus 3i b is equal to 0. Again, technically both should look similar, but if they do not, because one is the complex conjugate. So for example, if you multiply the first equation with 1 plus 3i, then you will see that you will get the second equation. Yes, it means that you can consider any one of the equation. So if I consider the first equation, which is 1 minus 3ia minus 2b is equal to 0. So there, if I took a is equal to 2 and b is equal to 1 minus 3i, this is the most easiest choice. Now I have the value of a and b. It means I can write my x and I can write my y. So now x is the constant a, so which is 2, and e raised to the power 3 1 plus it, which is 2 e raised to the power 3t, and cos 3t plus I sin 3t. Yes. Similarly, if you write y, then the constant is 1 minus 3i e raised to power 3t and cos 3t plus I sin 3t. Yes. Now y can be written as, you can, because in case of x, real and imaginary parts are visible, but in case of y also you need to write down the real and imaginary parts separately, and when you write them, then this is how it looks like. So now from here you can write down the two linearly independent solution. So one is 2 e raised to the power 3t cos 3t, and here cos 3t plus 3 sin 3t, and the next one is 2 e raised to power 3t sin 3t, and in this one also e raised to the power 3t would be multiplied, so e raised to power 3t, this is x, and similarly your y would be e raised to power 3t sin 3t minus 3 cos 3t. So these are the two required linearly independent solution. Now if you consider their linear combination, that gives you the required general solution. So we have discussed these three cases. The only thing which remains is the case when we solve the non-homogeneous system of equation. So that we'll consider in the next class. Just for the exercise, please do try at least these two questions, or there are many questions in the book as well. Thank you.